In the summer of 1942, the fate of the free world hung by a thread. Nazi Germany had turned Europe into a fortress, and the only weapon capable of piercing that shield was the Avro Lancaster, a four-engine heavy bomber of terrifying complexity. But as British factories crumbled under the relentless pressure of the Blitz, a desperate plan was hatched: move production to Canada. The British Air Ministry was insulted by the idea. They sent a chilling message to Ottawa, claiming Canadian industry was too primitive for such a machine. They believed Canada was a land of farmers and loggers, not master engineers. But they didn't know about Victory aircraft. They didn't know about a nation's ruthless determination to prove them wrong. This is the story of the KB700, the Ruhr Express, a machine made of 55,000 parts and built by a workforce that had never seen a bomber before. This wasn't just a project, it was a race against time, prejudice, and the very blueprints of war. Today, we uncover how Canada seized the failing factory and built the impossible. To understand the birth of the Ruhr Express, we have to look at the global crisis of 1941 and 1942. The Allied forces were losing the war of attrition. The Royal Air Force was burning through aircraft faster than they could be replaced. The Lancaster was the crown jewel of British aviation, a masterpiece of design by Roy Chadwick. It was a plane that could carry the massive Tallboy and Grand Slam bombs, the only weapons capable of destroying Nazi U-boat pens and mountain tunnels. Britain needed thousands of them, but their factories were sitting ducks for German bombers. Canada was the obvious choice for a second production line. It was safe from Luftwaffe raids, had vast natural resources, and was already part of the Commonwealth. However, the British Air Ministry in London held a deeply ingrained, almost colonial arrogance. Their official reports from that era suggested that Canadian workers lacked the technical temperament for technical aerospace precision. They argued that a plane as complex as the Lancaster required a generational lineage of craftsmanship that only the English Midlands possessed. In their eyes, Canada was where you got the spruce wood for a mosquito or the wheat for the troops, but not where you built a four-engine heavy bomber. At the heart of this tension was the National Steel Plant in Malton, Ontario. The factory was a disaster zone. It was plagued by labor strikes, incompetent management, and a lack of clear direction. They were struggling to produce even simple trainers and components. The British inspectors who visited Malton were horrified. They saw a plant that was disorganized and a workforce that seemed disinterested. London used this as evidence. They told the Canadian government, "We told you so, you simply aren't ready for a Lancaster." This was more than a production delay. It was a national insult to Canada's sovereign pride. Enter Clarence Decatur Howe, the Minister of Munitions and Supply. Howe was a man of cold, hard action. He knew that if Canada failed to build the Lancaster, it would be relegated to the status of a raw material supplier forever. He decided that if private industry couldn't handle the task, the government would. On November 4, 1942, Howe pulled off one of the most ruthless political maneuvers in Canadian history. Without warning, he used the Wartime Measures Act to expropriate the National Steel Plant. He literally seized the keys to the kingdom. He fired the entire board of directors in a single afternoon and replaced them with Victory Aircraft Limited, a crown corporation with one single goal. He didn't care about profit, he cared about the August 1943 deadline for the first flight. The takeover was a shockwave. Private business owners were terrified of Howe's power, but the workers on the floor felt a sudden shift in the atmosphere. The factory was cleaned, new lighting was installed, and a military-like discipline was introduced. Howe told the new management, "I don't care if you have to redraw every map in the building, that plane will fly by August." But the problems were deeper than just management. The British hadn't just sent blueprints, they had sent a puzzle that didn't fit together in North America. The drawings were in first-angle projection, while Canadians used third-angle. The measurements were in British imperial standards, which differed slightly from the American standard tools used in Ontario. The British had essentially set Canada up for failure by providing a design that was incompatible with Canadian machines. Victory Aircraft's engineers found themselves in a war of the blueprints. They had to translate an entire industrial language while the clock was ticking. They knew that every day they spent at the drawing board was another day that Canadian crews over Germany were flying older, more vulnerable aircraft. The pressure was suffocating. This was the moment the Ruhr Express began to transition from a dream into a cold, hard reality of steel and aluminum. The Canadians decided they wouldn't just copy the British Lancaster, they would re-engineer it to be better, faster, and easier to mass produce. They were going to show London that the colonial farmers were actually the future of aviation. When the crates from the Avro factory in Manchester finally arrived at the Malton plant, the engineers at Victory Aircraft didn't find a clear set of instructions. Instead, they found a technical disaster. In the 1940s, aircraft design wasn't as standardized as it is today. British engineering was an art form, passed down through generations of master craftsmen who knew how a part should fit, even if the drawing was slightly off. But in the high-speed world of Canadian mass production, feeling wasn't enough. You needed absolute mathematical precision. The first major hurdle was the sheer scale of the documentation. There were over 14,000 individual drawings for the Lancaster. Each one represented a piece of the 55,000-part puzzle. But as Chief Engineer Jim Bain and his team began to unroll the blueprints, they realized something shocking. They couldn't use a single one of them. The British used first-angle projection, a drafting style that essentially flipped the perspective of parts compared to the third-angle projection used in North America. To a layman, this sounded like a minor detail, but to a machinist, it was the difference between building a wing and building a mirror image of a wing that wouldn't fit the fuselage. The blueprint war had begun. Jim Bain made a ruthless executive decision. They would not try to work with the British drawings. Instead, they would redraw every single one of them from scratch. He converted a massive section of the factory into a drafting hall, filled with hundreds of designers working in shifts. They had to translate the entire aircraft into a Canadian industrial dialect. This meant changing every measurement to match North American tool sizes. For example, a British bolt might have a Whitworth thread, a specific pitch and angle used only in the UK. If a Canadian worker used an American standard bolt in a Whitworth threaded hole, it might seem to fit at first, but under the intense vibration of four 1,200 horsepower engines, that bolt would shear off, leading to a catastrophic mid-air failure. The tension in the drafting room was palpable. Every day, British technical advisors walked the floor, shaking their heads. They told the Canadians that redrawing the Lancaster would take years. They mocked the idea of improving on Roy Chadwick's original design. But the Canadians weren't just redrawing, they were simplifying. They looked at parts the British made from 3 or 4 separate pieces of hand-beaten metal and redesigned them to be stamped out by a single hydraulic press. They were taking a handcrafted British bomber and turning it into a mass-produced Canadian weapon. One of the biggest technical nightmares was the electrical system. The British Lancaster used a positive ground system with connectors impossible to find in Canada. Rather than waiting weeks for shipments across a U-boat-infested Atlantic, the Victory Aircraft team made a radical choice. They ripped out the entire electrical schematic and replaced it with a North American standard negative ground system. They redesigned the cockpit layout, the radio racks, the navigator station, all using parts sourced from local Ontario factories. It was a massive gamble. If the new electrical system failed, the plane would be a flying coffin. But the Canadians knew something. To meet C.D. Howe's August deadline, they had to be self-sufficient. While the engineers fought with paper and ink, the factory floor was being transformed. In Britain, Lancasters were often built in sections inside small garages, then transported to final assembly. It was slow, agonizing. The Canadians chose a different path. Influenced by the ruthless efficiency of the Detroit auto industry, they implemented a moving assembly line. They built massive steel structures called jigs, giant, immovable frames that ensured every wing, tail, and fuselage section was identical to the last. This meant if a Lancaster was damaged in combat in Europe, a Canadian-built replacement wing would fit perfectly. No hand filing, no massaging the metal. The British advisors were horrified. They thought the Canadians were too rigid, too mechanical. But Jim Bain understood the truth. This was the only way to build 400 bombers with a workforce that had never seen a heavy bomber before. The jigs became the silent masters of the factory floor. They removed guesswork from human hands and embedded precision into steel itself. By the time the 14,000th drawing was finished, the Canadians had done more than translate a plane. They had redesigned a Lancaster for the 20th century. They had turned an imperial bomber into an industrial bomber. The papers were signed, the blueprints were stamped, and the order went out to the factory floor. Start cutting metal. The blueprint war was over, but a far harder battle was coming next. Training 1,000 people who had never held a rivet gun to build the most complex weapon in the world. The British were still waiting for a cable from Canada that read, "We can't do it." That cable never came. Instead, the only sound rising from the Malton plant was the roar of hydraulic presses and the birth of a mechanical pulse that would one day be heard all the way to Berlin. With the redesigned blueprints finally in hand, Victory Aircraft faced its most daunting logistical hurdle, the human element. By late 1942, Canada's traditional industrial workforce, the men who had spent their lives in shipyards and steel mills, had been hollowed out. They were either already serving overseas or locked into other vital war industries. To build the Ruhr Express, the Malton factory needed thousands of workers, and they needed them immediately. What happened next was a social and industrial revolution the British Air Ministry had deemed impossible. The call went out across Ontario and beyond. It wasn't answered by seasoned aircraft mechanics or master craftsmen. Instead, the gates of the Malton plant were flooded by people who, just months earlier, had never even seen a heavy bomber. They were housewives from Toronto, teenagers from small rural towns, farmers from the prairies who had spent their lives fixing tractors, not four-engine bombers. The British observers looked at this ragtag assembly of civilians with open skepticism. To them, the Lancaster was a specialized machine that required generations of apprenticeship. They believed putting a rivet gun in the hands of a housewife was a recipe for disaster. But the Canadians had a secret weapon, the jig and fixture system. Because the engineers had spent months redrawing the blueprints for mass production, they were able to break the complex construction of the Lancaster into tiny, manageable tasks. A woman who had spent her life sewing clothes was taught how to follow a specific pattern of rivets on a wing panel. A farmer who understood the mechanics of a thresher was taught how to install the hydraulic lines for the landing gear. The factory floor became a massive, high-speed classroom. The Victory Army was born. It was a workforce fueled by a ruthless sense of personal mission. For many of the women on the line, this wasn't just a job. It was a way to protect their brothers, husbands, and sons already flying over Europe. They knew that a single loose fastener or a poorly soldered wire in the Lancaster's 50 miles of electrical cabling could mean 7 men would never come home. That emotional weight translated into a level of quality control arguably higher than anything seen in British factories. These amateurs were working with a precision born of love and fear. The atmosphere inside the plant was an assault on the senses. The air was thick with the smell of zinc chromate primer, that distinctive green paint used to protect aluminum from corrosion. The noise was deafening, a rhythmic thunder. At any given moment, 3,000 pneumatic rivet guns were firing simultaneously. Workers learned to communicate through hand signals and shouted instructions over the roar of machinery. Despite the chaos, the organization was surgical. The assembly line moved with the slow, inevitable crawl of a glacier. Every few days, a massive fuselage section was lifted by an overhead crane and mated to the wing center section. It was like watching a giant come to life, one rivet at a time. But the physical toll was immense. Shifts ran 10 to 12 hours, 6, sometimes 7 days a week. Women spent entire days doubled over inside cramped, freezing tail sections, their hands numb from constant vibration. There were no luxuries. The factory was hot, loud, dangerous. Yet morale remained unbreakable. They were proving the British Air Ministry wrong. Every time an inspector searched for a flaw and failed, a cheer rippled through the department. They weren't just building a bomber, they were building their bomber, and they intended to make it the best in the world. Slowly, the British advisors changed their tune. They watched in disbelief as a group of unskilled girls from Ontario assembled the rear turret, a machine filled with delicate gears and hydraulic motors, faster and more accurately than specialist crews in Manchester. The Canadian secret was standardization. Because parts were built inside rigid steel jigs, they fit together perfectly every single time. No hand fitting, no filing down, no hammering into place. The Canadian Lancaster was becoming a masterpiece of interchangeable parts. By the spring of 1943, the first aircraft, KB700, was no longer a collection of components. It was a silhouette, dark, looming, dwarfing everything around it. The workers had nicknamed it the Ruhr Express, a name that was both a promise and a threat. A message to the German industrial heartland that the farmers and housewives of Canada were coming. This is the heart of the documentary because it shatters the myth of the expert. It proves that with enough ruthless determination and the right engineering foundation, an entire nation can transform overnight. The Victory Army at Malton didn't just build a plane, they built a new Canadian middle class. They proved industrial excellence wasn't a British birthright, it was something that could be seized through hard work and innovation. As the calendar flipped towards August 1943, the pressure reached a breaking point. C.D. Ho was calling the plant daily. The British were still betting the deadline would be missed. But the unskilled workers had one last miracle left in them. They were about to roll the Ruhr Express out of the hangar and onto the tarmac, where the laws of physics would finally decide whether amateur hands had built a masterpiece or a tragedy. As the summer heat of 1943 settled over the Ontario landscape, the Victory aircraft plant reached a state of fever pitch. Inside the hangar, the Ruhr Express was undergoing what engineers call the final mating. This was the most critical stage of aircraft construction, the moment where the three massive sections of the fuselage, the nose, the center section, and the tail, were joined together. In British factories, this was a process of trial and error, days of shimming, adjusting, forcing parts to cooperate. But at Malton, thanks to the ruthless precision of Canadian steel jigs, the sections slid together with the clicking sound of a well-oiled machine. It was a moment of technical triumph that left British observers speechless. Once the airframe was whole, the veins and nerves of the giant had to be connected. More than 50 miles of electrical wiring, several miles of hydraulic tubing, all tested for leaks and continuity. The Victory Army of women workers crawled into the darkest corners of the wings and tail, using mirrors and flashlights to ensure every connection was perfect. They knew that at 20,000 feet, in the freezing darkness over Germany, there would be no room for error. The stakes were no longer industrial pride. They were measured in human lives. On August 1st, 1943, the order was given: fuel her up. For the first time, the massive wing tanks were filled with thousands of gallons of high-octane aviation spirit. Engineers stood by with fire extinguishers, watching for the slightest drip. Hydraulic systems were pressurized. The massive landing gear, thick steel legs designed to absorb a 30-ton landing, were cycled up and down. Everything worked. The amateur hands of the Canadian workforce had produced a machine that, on paper, was flawless. Then came the engines. The Rolls-Royce Merlin is not just an engine, it is a temperamental masterpiece of engineering. Bringing 4 of them to life is a mechanical symphony. As ground crews hand-cranked the propellers to prime the cylinders, a hush fell over the thousands of workers gathered at the hangar doors. Captain J.D. Smith, the test pilot, climbed into the high, glass-enclosed cockpit. He checked his gauges, gave a thumbs up, and hit the starter for engine number 1. The sound was a physical blow to the chest. A cloud of blue smoke erupted from the exhaust stacks. Sharp cracks. Then, the low, rhythmic growl of the Merlin settled into a steady roar. One by one, the other 3 engines followed. The vibration was so intense, it rattled the windows of the factory office half a mile away. The Ruhr Express was breathing. It was no longer a collection of parts. It was alive. The date for the first flight was set, August 6, 1943. C.D. Howe arrived from Ottawa, his face a mask of ruthless expectation. The British Air Ministry sent their top technical advisors, still half expecting failure. The world's press lined the tarmac. But inside the workforce, the mood was different, quiet, focused, almost prayerful. They had lived with this plane for 9 months, bled for it, sweated for it, lost sleep for it. Captain Smith taxied the giant to the very end of the Malton runway. The Lancaster looked impossibly large, a dark shadow against the summer sky. To those watching, it seemed inconceivable that something so heavy, built by people who had never built a plane before, could actually fly. Smith held the brakes and pushed the throttles forward. The 4 Merlins screamed to full power. The aircraft shook violently. Then he released the brakes. The Ruhr Express began to roll, slow at first, almost lumbering. 500 yards, 1,000 yards, the tail stayed down. British observers gripped their clipboards. Then, at 1,500 yards, the tail lifted. The aircraft leveled, accelerated, and then, with a grace that defied its size, the wheels left the ground. The Ruhr Express was airborne. A roar erupted from the ground, louder than the engines. Workers cried, hugged, threw hats into the air. But in the cockpit, Joe Smith stayed focused. This wasn't just a flight, it was a test. He climbed to 10,000 feet and began a series of ruthless maneuvers, steep banks, stall tests, structural limits pushed. He listened for oil canning, the terrifying sound of aluminum skin buckling. He heard nothing. The Canadian jigs had done their job. The airframe was stiff, true, a diamond. After 2 hours, Smith brought the giant home. He flared the nose. The massive tires kissed the tarmac with a soft puff of blue smoke. As he taxied back, Smith leaned out of the window and waved. His report was brief and devastating to British skeptics. She flies better than the Manchester builds. The impossible had been achieved. In 9 months, Canada had seized a failing factory, redrawn 14,000 blueprints, trained an army of housewives, and built the most complex aircraft on Earth. The Ruhr Express wasn't just a success, it was a revolution. Canada was no longer a junior partner, it was an industrial superpower. But the celebration didn't last long. As the engines cooled, C.D. Howe approached management. No speech, no applause. He glanced at the next airframe already waiting in the hangar and said, "Now, give me one a day." The secret war of production was over. The real war, the one that would carry the Ruhr Express into the heart of Germany, had just begun. The Ruhr Express was no longer a local celebrity in Ontario. It was now a weapon of war. But before it could strike a single blow against the Third Reich, it had to survive the most treacherous delivery route in the world, the North Atlantic Ferry. In the winter of 1943, KB700 lifted off from Gander, Newfoundland, headed for the United Kingdom. A 3,000-mile journey over freezing, U-boat-infested waters in an era before GPS or reliable long-range weather forecasts. The Canadian crew sat in the unpressurized cockpit, shivering in fleece-lined suits, listening to the rhythmic drone of the Merlins. If one engine failed out there, the Atlantic would become their grave. But the ruthless build quality of the Malton plant held true. KB700 touched down in Scotland, ready for its baptism of fire. The aircraft was assigned to the Royal Canadian Air Force's 419 Moose Squadron, based at RAF Middleton St. George. It was here that the Ruhr Express met its first combat crew, 7 young men, mostly in their early 20s, who looked at the massive bomber with a mixture of awe and terror. They were the ones who would take this Canadian masterpiece into the cauldron. Their mission was clear: participate in the Battle of the Ruhr, a sustained aerial assault designed to pulverize the industrial heart of Germany, the very place for which the plane was named. The life of a Lancaster crew was a mathematical nightmare. The odds of surviving a full tour of 30 missions were less than 50%. Every time the Ruhr Express taxied out for a night raid, the crew knew they were entering a 3-dimensional battlefield. Below them, thousands of German 88 guns throwing walls of high explosive shrapnel into the sky. Around them, hidden in pitch-black darkness, German Nachtjagd night fighters, equipped with early radar and Schrägemusik, upward-firing cannons designed to rip through the unprotected belly of a bomber. On its first few missions, the Ruhr Express proved to be a lucky ship. While other bombers fell in flames, KB700 seemed to possess a supernatural resilience. On one raid over Berlin, the aircraft was caught in a cone of 20 searchlights. For a bomber pilot, this was a death sentence. Once illuminated, every gun for miles would zero in. Captain Bill Plesk threw the 30-ton giant into a ruthless corkscrew, a violent diving maneuver pulling 3 Gs, far beyond what the aircraft was designed to handle. The aluminum groaned, the rivets strained, but the Canadian airframe held. They slipped free and vanished back into the darkness. The crew began to notice something different about their Canadian-built Lancaster. It felt better. Because of the standardized jigs and the negative ground electrical system, KB700 was easier to maintain. While British Lancasters were grounded by endless electrical faults, the Ruhr Express was always ready. Ground crews called it a mechanical marvel. It became a source of immense pride for the RCAF, a plane built by their mothers and sisters back home, outperforming everything on the base. But war is a process of attrition. By its 25th mission, the Ruhr Express was no longer pristine. Its camouflage was scorched, its fuselage patched and scarred by flak damage. On a raid over Essen, a flak fragment the size of a dinner plate smashed through the navigator's table, missing him by inches. The bomber flew home with a gaping hole in its side, freezing wind howling through the cabin, yet the 4 Merlins never missed a beat. The Ruhr Express was more than a bomber. It was a psychological weapon. News of its 40th, then 45th mission was broadcast back to Canada. In Malton, the women of the Victory Army gathered around radios. They knew this plane. They knew who riveted the port wing. There was a living connection between the factory floor in Ontario and the flak-filled skies over Germany. But its luck would be tested one final time. On January 2nd, 1945, KB700 lifted off for its 49th mission. Target: Nuremberg. The bombs were delivered with ruthless precision, but on the return, weather closed in, a massive fog bank over the North Sea. The landing became a blind gamble. As the Ruhr Express touched down at Middleton St. George, something went wrong. Whether battle damage or mechanical failure, we will never know. The port landing gear collapsed. The wing struck the ground. The bomber spun violently. Fuel lines ruptured, and within seconds, the Ruhr Express was engulfed in flames. The crew scrambled out, some leaping through the fire. Miraculously, all 7 survived. They stood shivering on the runway, watching the first Canadian Lancaster burn down to a blackened skeleton. It was a heartbreaking end to a legend. The KB700 had survived the Nazis, the Atlantic, and London skeptics, only to fall on its own runway. But its legacy was already sealed. 49 missions, more than double the average lifespan of a heavy bomber. It proved that Canada didn't just belong in the war, Canada was leading it. The forbidden bomber had become the unstoppable legend, and its death only fueled the fire for the 430 Canadian Lancasters now rolling off the line, 1 per day. As the fires of World War II finally flickered out in May 1945, the victory bells ringing across Canada carried a bittersweet note for the workers at Victory Aircraft. The Ruhr Express was gone, but the industrial monster it had birthed was now at its peak. In less than 3 years, the Malton factory had transformed from a disorganized mess into one of the most efficient aerospace hubs on the planet. They had produced 430 Lancasters, each one a testament to the ruthless engineering standards established by that first impossible prototype. But as the soldiers returned home, a new battle began, the battle for Canada's industrial future. The British Air Ministry, which had once mocked Canadian amateurism, was now forced to admit that the Canadian-built Lancasters were among the finest in the world. However, with the war over, the massive contracts were cancelled overnight. The Victory Army of housewives and farmers was sent home. The hangar doors that had seen the birth of a legend were suddenly quiet. But the knowledge, the deep technical DNA of the Ruhr Express didn't just vanish. It laid a foundation that would catapult Canada into the jet age faster than anyone could have predicted. The engineers who had redrawn those 14,000 blueprints in the War of the Blueprints now had the confidence to stop copying others and start inventing for themselves. In 1945, Victory Aircraft was sold to Hawker Siddeley Group and became Avro Canada. The same factory floor where the Ruhr Express was riveted together became the birthplace of the Avro jetliner, the first jet transport in North America, flying only 13 days after the world's first jetliner in Britain. The unskilled workforce had become the elite of the aerospace world. This lineage led directly to the most famous ghost in Canadian history, the Avro CF-0105 Aero. The Aero was a supersonic interceptor so advanced that it was decades ahead of anything the United States or the Soviet Union was building. When you look at the titanium structures and the complex internal systems of the Aero, you are looking at the direct evolution of the lessons learned on the KB700. The ruthless precision, the standardized jigs, the defiance against those who said it can't be done. It all started with the Ruhr Express. But history is often cruel of its pioneers. Just as the Ruhr Express was hidden from the spotlight by colonial politics, the Avro Aero was famously cancelled and its prototypes destroyed in 1959. For decades, it seemed like Canada's aerospace glory was a series of near misses and forgotten victories. The workers of the No. 2 Construction Battalion and the Rosie the Riveters of Malton were pushed into the shadows of history books. Their contribution was treated as a temporary wartime necessity, not a permanent national achievement. It wasn't until the 21st century that the true weight of the Ruhr Express story began to be felt. Modern historians started digging through the archives, uncovering the letters from the British Air Ministry that revealed the depth of the prejudice Canada had faced. They found the names of the women who had signed the inside of the fuel tanks, names now being honored by their grandchildren. In 2022, as part of a broader national movement to recognize the forgotten heroes of the war effort, the story of the Lancaster workers was finally given the official recognition it deserved. The Ruhr Express is now more than just a crashed bomber on an English runway. It is a symbol of a nation's coming of age, a reminder that expertise is not something you're born with or something that belongs to an old world empire. It is something you build with your own hands through sleepless nights and a refusal to accept second-class status. The 14,000 blueprints, the 55,000 parts, and the 600-strong battalion of engineers created a bridge from a colonial past to a high-tech future. Today, if you visit the Canadian Warplane Heritage Museum in Hamilton, Ontario, you can hear the roar of the Mynarski Memorial Lancaster, one of only 2 airworthy Lancasters left in the world. When those 4 Merlin engines start, the ground shakes with the exact same frequency as it did on that August morning in 1943. It is a haunting, beautiful sound. It is the sound of the Victory Army still speaking to us, telling us no challenge is too great, no blueprint too complex, and no critic too loud when a people decides to be ruthless in their pursuit of excellence. The Ruhr Express died so that the spirit of Canadian innovation could live. It proved that a factory full of amateurs could build a machine that saved the world. As the last veterans of the Malton plant pass away, their story remains etched in every rivet of the planes that still fly. They took the forbidden and made it fundamental. They were the engineers of a new world, and the Ruhr Express was their masterpiece. If you've stayed with us through this 50-minute journey into history, it's because you understand that the past isn't just about dates, it's about the people who dared to prove the world wrong. The KB700 Ruhr Express wasn't just a bomber, it was Canada's declaration of independence. If you found this story powerful, please share it. Hit the like button to ensure the algorithm keeps these hidden histories alive, and subscribe for more deep dives into the machines and the heroes that history almost forgot. The Ruhr Express may have burnt out on that runway, but its legacy is still in the air. Thanks for watching.